Alright, so we're looking at the P11 video. This is the beginning of polynomial graphing. So we're going to be trying to we're going to try and graph polynomial functions. And ultimately our goal for this video, we're going to use characteristics of polynomial functions to determine end behavior, number of possible turns, and then we're going to draw a really rough sketch of a graph. So there's three big goals that we have here, and we're going to be using characteristics of those of polynomials in order to do those things. Now, the two big characteristics that we want to pay attention to, the first one is going to be the degree. Now, again, the degree of a function, that is the largest exponent. We all know that. Right, we've dealt with this one before. And then we're going to use the leading coefficient. All right, so that is the number in front of the variable that has the largest coefficient, the largest exponent. So the leading coefficient is the number. So the number in front of the variable that has the largest exponent. Okay, so these are the two things, the degree and the leading coefficient, that we're going to look at in order to be able to do these three things, okay? Now, I want to get you to familiar with a few graphs, and then we're going to take a look at end behavior. So the first graph I want to take a look at is this one here. So this is the graph of f of x equals x squared. And the degree here, so our degree is 2. All right, so the degree is 2. Our leading coefficient is a positive 1. All right, so 1. All right, the number in front of x squared, the number right here in front of x squared is just a 1. And whenever it comes to end behavior, what we're going to be looking at is the arrows that point. So here's one arrow here, and here's the other arrow, the end of the graph. Right? We have two different arrows. Okay, so here we have x squared, and notice that both arrows are pointed in the same direction, and they're both pointed up. And let's take a look. This graph has one turn, right? So it was going down, 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 and all of a sudden now it's going up, 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 up. Right, so this has one turn. There's one turn here. So here the degree is 2, the number of turns we have is 1. That's going to come into play a little bit later. Let's take a look at this graph here. Here's the graph of x cubed. It's actually x cubed plus 2. Don't worry about all that. Here's the part I'm really focused in on, is the degree of this one is a 3. And let's take a look here. My arrows, I have one arrow pointed down, and I have one arrow pointing up. The leading coefficient on this one is a positive 1. And the other thing I wanted to say about this one, let's take a look at the turns. Here I'm going up, 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 and it takes a turn, starts going down, it takes a turn, and then it's going up, 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 up. All right, so this one has 2 turns. Let's take another look at another one here. Here's a function, x to the 4th. All right, so the degree is 4. Again, my leading coefficient is just a 1. And now let's take a look. Here my arrows have one going that direction, another one going that direction. Both of my arrows are pointed up. All right, my left side arrow is pointed up, my right side arrow is pointed up. And now let's take a look at the number of turns. All right, so I'm going down, 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 turn, and I go up, 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 turn, down, 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 turn, up, 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 up. So this has 3 turns. Now let's take a look at one more graph, and then we can start to really put some of these patterns together. Oh, sorry. What? Yeah. Here we go. All right. So here, this is the graph of some x to the fifth. It's got some other stuff with it, but what I'm really worried about is that here, my arrows, my left arrow pointed down, my right arrow's pointed up. The degree is a 5. My leading coefficient is a 1 to positive 1. And let's take a look at the number of turns we have. Here I go up, 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 turn, go down, 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 turn, up, 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 turn, down, 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 turn. So there are 1, 2, 3, there are 4 turns. So, several things that we could take a look at here. And I want to, just now that you're a little bit more familiar with these, now I'm going to break them down into the 3 things that we need to do. End behavior, number of turns, and then we're going to start sketching basic little graphs. So let's take a look at end behavior. End behavior. Well, what does that mean? It's where are the arrows pointed on the left and right side of the graph. They're either pointed up or down. Right, so these are the options. The answer is going to be up or down. Now we need to be smart about what we say. Left and right side, well, there's a particular way of writing that. So let's take a look at our first graph that we had here. Let's take a look at these x values here. Those x values keep going on forever and ever and ever and ever, and they end up, well, here we have -1, -2, 3, -4, -5, -6. If we kept going in the negative direction, we'd end up at -infinity for x. And the same thing over here. If I kept going to the right, and I kept going 2, 3, 4, 5, 6, da 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 da, for as long as I could, I'd end up going to infinity. Same thing down here. If I kept going down, 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 I'd go to -infinity for the y. And if I kept going up, 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 I'd go to +infinity for the x. Or excuse me, for the y, I'd be going +infinity for y. X, here's -infinity and +infinity. So left is -infinity for x. Right is +infinity for x. Down is -infinity for y. Up is +infinity for y. So let's see how that goes into play here. There's those 2 characteristics, the degree and the leading coefficient. I'm going to make this chart here. Make this box as big as I can. All right, so here I'm going to write leading coefficient. Now there's 2 options for the leading coefficient. The leading coefficient can either be positive or the leading coefficient can be negative. And there's 2 possibilities. There's 2 possibilities for the degree. The degree can either be even or the degree can be odd. So, when it comes to the end behavior, and I'm just talking about the arrows, I'm not talking about the stuff in the middle, but just these arrows, just the arrows, right? Then we have what's going on here. So if it's positive and even, then I have both of my arrows, and it doesn't matter what's going on in the middle, but both of my arrows are pointed up. And how we say this is we say as x approaches negative infinity, right? So negative infinity would be to the left. Okay, so as x approaches negative infinity to the left, then my y value, f of x, is going up. So that means it's approaching positive infinity. All right, so when we go to the left, the arrow is pointed up. So when we go to the left, the arrow is pointed up. And now as x approaches regular positive infinity, so that's, x approaches positive infinity, we're talking about to the right side, then y, my f of x, my y values, are going up. And now if I had a negative leading coefficient and the degree is even and I have negative coefficient, then my arrows would both be pointed, again, doesn't matter about the middle, but my arrows would both be pointed down. So how do we say that? Well, we say as x approaches negative infinity, then f of x approaches negative infinity, right? Because I'm going down. So on the left side, the arrow is pointed down. On the left side, the arrow is pointed down. And now we say as x approaches positive infinity, right, to the right, well, on the right side, then my arrow is pointed down. So let's take a look at what happens when the leading coefficient is positive and the degree is odd. Well, here we go. When the leading coefficient is positive, the degree is odd. Well, my arrows are now cattywampus, right? One's up, one's down. So on the left side, the arrow's pointed down. Again, I don't care what's happening in the middle. And on the right side, the arrow's pointed up. So as x approaches negative infinity, then my y value is going to approach negative infinity, right? To the left, the y value is pointed down, so the arrow is pointed down. As x approaches positive infinity, in other words, to the right, then my arrow is going to be pointed up. And if I had a negative leading coefficient, then on the left side, the arrow would be pointed up. All right, if my degree is odd and I have a negative coefficient, left side's pointed up, and the right side is pointed down. So we would say as x approaches negative infinity, the left side, then the arrow is pointed up. All right, so as x approaches negative infinity to the left, the y values are going up. So as x approaches positive infinity, then my y values are pointed down. We have another video where I go over examples on how we're going to look at these.